Located 6,500 light-years away, three seemingly eerie fingers stand tall in the depths of the cosmos. Each of them is 7 light-years high, longer than the distance from the Sun to the nearest star. These are the pillars of creation. Since the launch of the Webb telescope, it has sent back many photos that make me feel both fear and shock, because they prove one thing. At the beginning of the universe, in that darkness which should have been empty, there were hidden so many huge and unexplainable things. If you haven't seen them yet, then next, I will take you to see 16 terrifying celestial bodies captured by the Webb telescope at once, each of which is enough to overturn your and my understanding of the universe. First, let us explore the beauty of the pillars of creation. These towering structures made of cosmic dust and gas are one of the most fascinating sights in the universe. Thanks to infrared technology, we can now penetrate these dense pillar structures to witness the birth of new stars. Standing about 7 light-years tall, these pillars are part of the Eagle Nebula, a stellar nursery. The iconic pillars of creation, located 6,500 light-years from Earth, first became famous in 1995 when the Hubble Space Telescope photographed them. Today, the Webb telescope reveals even more of their hidden beauty. Hubble's view was limited to visible and ultraviolet light, unable to penetrate cosmic dust and gas, thus failing to fully reveal the mysteries within. Webb, utilizing infrared light, can pierce through these dust-shrouded cradles to show the newborn stars shining inside. This detailed image shows that these newborn stars indeed steal the show. At the edges of some pillar structures, glowing wavy red lines can be seen, resembling lava flows. These are actually streams of matter ejected by young stars. When these supersonic jets collide with dense clouds of gas and dust, they form striking red bow shocks. The light of thousands of stars flickers throughout the scene, illuminating the towering pillars as they stand majestically against the vast cosmic background. This is the pillars of creation from Webb's perspective, giving us a glimpse into the dynamic process of star formation and displaying the beauty and power of the universe in an unprecedented way. The Southern Ring Nebula is a planetary nebula, referring to the glowing shells of gas and dust left behind when a dying star ejects its outer layers. It is located in the constellation Vela, about 2,500 light-years from Earth. The Hubble Space Telescope had previously photographed this nebula, but the James Webb Space Telescope's infrared instruments now provide us with a clearer viewing angle, revealing this object in greater detail and with more stunning scenery. One of the key discoveries of Webb's observation is the clearer presentation of the stars at the center of the nebula. Previously, only one star, a hot white dwarf, was clearly visible, but Webb's infrared observational capabilities allow astronomers to clearly observe both stars in the binary system. What is particularly striking about the Webb image is the complex structure of the nebula itself. It is not a single ring structure, but is composed of multiple concentric shells. Each layer of gas radiating outward from the center represents matter ejected during different stages of the dying star's life. This layered structure reveals how the nebula has expanded over time under the influence of stellar winds and radiation, forming the chaotic yet amazing patterns we see today. The interaction between the stars and the ejected matter gives us a glimpse into the final stages of stellar evolution, transforming death into an exceptionally beautiful cosmic wonder. One of the most delightful sights and surprises brought by the James Webb Space Telescope is the spectacular image of Saturn it captured. Typically, Saturn looks smooth and pale with its rings barely visible. However, infrared images taken by the Webb telescope show the planet's dim hue while its bright rings stand out remarkably. This contrast occurs because methane gas in Saturn's atmosphere absorbs most of the sunlight in the infrared wavelengths used by Webb, making Saturn appear dim against the shadowy background, while the icy rings shine dazzlingly, displaying their unique charm. They present a brilliant glow like vibrant, thick horizontal bands shining with snow-white light, effortlessly outshining the dim Saturn in the background. These rings are a mix of ice and rock particles, ranging in size from grains of sand to towering mountains, reflecting large amounts of infrared light. In this Webb image, we capture details of the A, B, and C rings, as well as the fainter F ring, and even the Cassini division and the narrow gaps between the rings. Astronomers also noted two mysterious phenomena in this photo of Saturn. First, an unusual glow was observed at the edge of Saturn, which may be caused by methane fluorescence, a process where atoms absorb light and emit it at a different frequency. Another theory suggests this might be caused by emission from abundant trihydrogen cations, H3+, in Saturn's upper atmosphere, or perhaps a mixture of both phenomena. The second mystery lies in the peculiar patches appearing in Saturn's northern hemisphere. These patches may be caused by gravity waves interacting with aerosols in the upper atmosphere, but the specific process remains unclear. The Webb image also captured three of Saturn's moons, Enceladus, Dione, and Tethys. Enceladus particularly fascinates scientists because life might exist beneath its icy surface. Enceladus's subsurface ocean and its geysers, which periodically eject water vapor into space, contribute to the formation of Saturn's faint E-ring, making Enceladus a key target in the ongoing search for extraterrestrial life in our solar system. When the James Webb Space Telescope captures those breathtaking images, they initially do not look as stunning as the final versions we see. Astronomers acquire raw infrared data, invisible to our naked eyes, and, through processing and colorizing, bring these celestial wonders to life before us. It is a fascinating transformation, turning the invisible into a vivid masterpiece. This image presents one of the deepest and sharpest views of the universe ever taken in infrared light, allowing us a glimpse into the distant cosmos. The image features SMACS 0723, a massive galaxy cluster located in the constellation Volans, about 4.6 billion light-years from Earth, known as Webb's first deep field. This breathtaking image displays thousands of galaxies, including some of the most distant galaxies ever observed. The image demonstrates the power of gravitational lensing, a phenomenon where the massive mass of SMACS 0723 bends and magnifies light from more distant galaxies behind it. This cosmic magnification effect allows the Webb telescope to look back into the past, observing galaxies as old as 13.1 billion years, formed less than a billion years after the Big Bang. The details revealed by Webb in this image are unprecedented, containing some of the farthest galaxies ever detected, more than 13 billion light-years from Earth. The ability to observe these ancient galaxies enables scientists to explore the early universe and gain deep insights into the formation and evolution of galaxies. This image, released in July 2022, is one of the first full-color images taken by the James Webb Space Telescope, powerfully demonstrating its extraordinary observational capabilities. What you are seeing now is the aftermath of a star explosion, whose light arrived on Earth about 340 years ago. This is the Cassiopeia A supernova remnant, located about 11,000 light-years away. The image taken by the James Webb Space Telescope reveals a complex scene of interwoven gas and dust, highlighting the debris of the exploded star. The inner shell of Cassiopeia A displays vivid colors. Bright pink and orange represent various elements such as sulfur, oxygen, and neon. These elements were ejected during the supernova explosion and are now clearly visible thanks to Webb's advanced infrared imaging capabilities. In the close-up image, the outer edges of Cassiopeia A present a ghostly haziness because cooler dust emits less infrared light, contrasting with the brighter radiation captured by Webb. This contrast illustrates how different temperatures affect the visibility of cosmic matter. One of the most fascinating discoveries in this image is the remnant known as Baby Cass A, a light echo that is essentially a blob of dust illuminated by high-energy photons generated by the original supernova explosion. Located about 170 light-years behind the main remnant, Baby Cass A glows brightly in infrared due to the heat generated by these high-energy photons. The entire diameter of Cassiopeia A reaches 10 light-years, or 60 trillion miles. With the James Webb Space Telescope, we can now see how this dying star completely shattered when it exploded, leaving behind filaments resembling tiny shards of glass. Neptune is one of the least explored planets in our solar system, remaining a mystery for a long time due to its extreme distance from Earth. However, the James Webb Space Telescope has provided us with a stunning new view of this distant ice giant, revealing details never seen before. One of the most exciting aspects is that the Webb image clearly displays Neptune's rings. a sight we haven't seen so clearly in 35 years. The last time Neptune's rings were observed with such clarity dates back to 1989, when the Voyager 2 probe completed its historic flyby. Even advanced telescopes like Hubble struggle to capture these faint rings due to their low reflectivity and Neptune's distance from the Sunday. Webb, utilizing its near-infrared camera, captured the complex structure of Neptune's rings in amazing detail. This image not only reveals Neptune's main rings, but also shows faint dust bands surrounding the planet. These dust bands consist of particles encased in dark ice, which are more clearly visible in the infrared spectrum, the very strength of Webb's imaging. This makes this Webb image the best image of Neptune's rings we have obtained in over 30 years. Another fascinating detail in the Webb image is the form of Neptune itself. Due to the presence of methane, Neptune is usually depicted in striking blue. However, in the James Webb Space Telescope image, Neptune appears white because methane absorbs light in the infrared spectrum, making the planet appear darker at these wavelengths and leaving a ghostly white appearance in the image. We can also see bright clouds in Neptune's atmosphere, especially near its poles. These bright spots are high-altitude methane ice clouds, similar to cirrus clouds seen on Earth. A thin, bright line circling the planet's equator may be a visual feature of global atmospheric circulation. In addition to Neptune itself, Webb also captured a magnificent view of Neptune's largest moon, Triton. In this infrared image, Triton appears as a bright point of light, even brighter than Neptune. This is because Triton reflects far more sunlight in the infrared band than Neptune, whose methane-rich atmosphere absorbs most of the sunlight in that band. Triton's dazzling glow, combined with the new details of Neptune, makes this photo one of the most spectacular images of an ice giant and its satellite to date. This is part of the first batch of scientific images released in 2022. The cosmic cliffs are a magnificent region within the Carina Nebula, located about 7,600 light-years from Earth. Webb's released image of this region presents a stunning three-dimensional view, resembling rugged mountains under moonlight. In reality, the image shows the edge of a giant gaseous cavity within NGC 3324. The tallest peaks in the cosmic cliffs stretch about 7 light-years, equivalent to an astonishing 42 trillion miles. These cliffs, stretching for trillions of miles, were sculpted by intense ultraviolet radiation from massive stars located outside the image frame. These young hot stars eject radiation and stellar winds that blow away gas and dust, thus shaping the cosmic landscape we see. Webb's infrared imaging technology reveals numerous young stars and protostellar jets, streams of gas ejected by stars still in the process of formation. These jets appear as bright streaks in the image. Astronomers detected 24 new molecular hydrogen outflows in this area, further proving the intense star formation activity within the nebula. Notably, many such star-forming regions were previously obscured by thick clouds of gas and dust. These cosmic cliffs are not only visually stunning, they also provide valuable clues for us to understand the birth of stars and how their intense radiation shapes the surrounding nebula, thereby influencing future star formation. Next is the deep space image of Pandora's cluster, ABEL 2744, released by Webb. This galaxy cluster is about 4 billion light-years from Earth. This image is a major achievement. It combines 4 separate snapshots into a magnificent panorama, revealing an incredible 50,000 near-infrared light sources. A surprising fact is that the mass of galaxies within Pandora's cluster accounts for only about 5% of its total mass, while about 20% of the mass consists of hot gas. This gas is so hot that it emits X-rays. However, the majority of the cluster's mass is made of dark matter. One of the most striking features in this image is the gravitational lensing phenomenon. The cluster's immense mass bends and distorts light from more distant galaxies behind it, effectively acting as a cosmic magnifying glass. This lensing effect allows astronomers to observe galaxies that would otherwise be too faint to detect. In the lower right corner of the image, many arc-like streaks can be seen. These are distorted and magnified images of distant galaxies, giving us a glimpse into the structure of the early universe. Pandora's cluster with its complex gravitational interactions and dark matter dominance, offers an excellent window for us to understand the cosmic forces shaping the universe. Next up is the Grand Design Spiral Galaxy, also known as the Phantom Galaxy or M74, located in the constellation Pisces, about 32 million light-years from Earth. This galaxy exhibits a textbook spiral structure with prominent sweeping arms. The James Webb Space Telescope captured the Phantom Galaxy's bright central core and the spiral arms extending outward, displaying them in extremely fine detail. These arms present rich orange tones, indicating that these regions are rich in star-forming material. These dust lanes harbor abundant elements for the birth of new stars, creating a vibrant environment for starbirth in the galactic core. Webb's image shows a blue haze, indicating the presence of older stars. This central region is densely packed with star clusters, actively contributing to the galaxy's brightness and forming a bright, glowing center. This is not the first time the Phantom Galaxy has been photographed. The Hubble Space Telescope previously captured stunning views of the M74 galaxy in visible light, showcasing its classic spiral structure and highlighting the distribution of stars and star-forming regions. In Hubble's image, the galaxy's arms emit blue light from young, hot stars, vividly displaying the areas where star formation is most active. However, Hubble's observations were limited by its inability to penetrate the dense dust and gas obscuring parts of the galaxy's internal structure. In contrast, the James Webb Space Telescope's infrared observational capabilities allow it to pierce through these dust clouds, observing the inner workings of M74 from an unprecedented perspective. This enables astronomers to pinpoint specific regions where new stars are born and analyze the chemical composition of these areas in detail. On the 27th of July 2022, the James Webb Space Telescope captured this extraordinary photo of Jupiter, revealing unprecedented details. In Webb's image, Jupiter appears in fascinating shades of pale pink, dark blue, and white, thanks to the telescope's infrared imaging capability. It can penetrate Jupiter's thick atmosphere, allowing us to understand how different cloud layers reflect sunlight. The bright equatorial region stands out in these images, where high-altitude haze scatters light to form a sharp contrast. Jupiter's iconic Great Red Spot is also clearly visible. This massive storm, larger than Earth, has been raging for over 350 years. Interestingly, in Webb's observations, the Great Red Spot appears white rather than red due to the strong reflection of the infrared spectrum by high-altitude clouds. One of the most exciting features discovered by Webb is the spectacular auroras at Jupiter's poles. These auroras are produced by the interaction of charged particles from the Sun with Jupiter's powerful magnetic field. Since Jupiter's magnetic field is much stronger than Earth's, its auroras are also more intense and cover large areas of the polar regions. Webb's infrared imaging function also provided an impressive view of Jupiter's faint rings. These rings are far less prominent than Saturn's, but are still fascinating. These thin dust rings, first discovered by the Voyager probe in 1979, are mainly composed of tiny rock and dust particles. They are believed to originate from impact events on Jupiter's moons, where ejected material spread out to form these delicate ring systems. The images of Jupiter provided by Webb not only display its beauty, but also offer rich information about its atmospheric dynamics, magnetic field, and the various forces shaping its environment. The small red dot you see is Arundel, WHL 0137LS. It is the most distant star discovered in the universe to date, located near the edge of time. The light from Arundel has traveled an astonishing 13 billion years to reach us, but due to the expansion of the universe, its true distance is much farther, about 28 billion light-years away. This amazing discovery resulted from a cosmic coincidence. The alignment of a massive galaxy cluster in the foreground utilized gravitational lensing to magnify the light of Arundel, allowing us to observe this distant star. Arundel was initially discovered by the Hubble Space Telescope. Hubble observed its host galaxy, which was being affected by gravitational lensing, forming a stretched and curved structure. Scientists named this structure the Sunrise Arc. Within this arc, they detected an unusually bright object, but its volume was too small to be a galaxy. After further study, Astronomers determined that this bright object was magnified at least 4,000 times, indicating it is an extremely distant gravitationally lensed star. Based on Hubble's observations, Arundel was classified as a massive B-type star, about 1 million times brighter than the Sun and more than twice as hot. However, when the James Webb Space Telescope observed Arundel, it revealed something new. Webb's advanced infrared detection capabilities detected a cooler, redder companion star near Arundel. This object, not found in previous Hubble observations, opens up exciting possibilities for studying this ancient star system. The discovery of Arundel is significant because it may give us our first glimpse of population 3 stars. These are the first stars formed after the Big Bang. For years, population 3 stars have been a focus for astronomers because they were composed entirely of primordial hydrogen and helium and may have played a key role in the evolution of the early universe. Astronomers expect Arundel to remain magnified for years to come, allowing the James Webb Space Telescope to conduct more detailed observations. These follow-up studies may help reveal the exact nature of this star and its companion, providing us with a rare opportunity to peek into the early stages of cosmic history. Arundel represents a star born near the cosmic dawn, while the next image shows a protostar about to be born, L1527, hidden within a dark cloud. This protostar is concealed within a striking hourglass-shaped structure, with a dark line in the center representing the protoplanetary disk. Light from the forming star passes through the disk, illuminating the surrounding gas and dust. In the close-up image, blue and orange represent different dust layers. Blue areas indicate thinner dust, allowing more light to escape, while orange areas indicate thicker dust, where more light is absorbed. This color contrast vividly displays the complex interaction between light, gas, and dust. As the protostar matures, dust continues to accumulate. L1527 is about 100,000 years old, a very young Class 0 protostar in the early stages of star formation. At this stage, it has not yet begun nuclear fusion, the process that powers mature stars. As L1527 continues to accumulate mass, its core material will be compressed, eventually reaching the critical temperature required to trigger nuclear fusion. This will mark its transition into a mature star. From the perspective of L1527, we can catch a glimpse of what our solar system might have looked like in its early form. These images provide valuable clues for us to understand the early stages of star formation and the formation processes of stars and planets. Uranus is one of the least explored planets in the solar system, with only the Voyager 2 probe having flown past it. However, detailed images of this ice giant taken by Webb have revealed previously unknown features. Most striking are its vibrant rings. Previously, only Voyager 2 and the Keck Observatory had photographed these rings. This observatory, equipped with advanced optical systems and utilizing infrared observation capabilities, was able to capture the brightness and structure of Uranus's rings. These rings are difficult to detect in the infrared band, including the elusive Zeta ring. Now clearly resolved, the Zeta ring allows astronomers to gain a deeper understanding of its characteristics. Uranus is known to have 13 rings, 11 of which can be seen in the Webb image. Some rings are so bright in the infrared that when observed close together, they appear to merge into a larger ring. Another fascinating feature captured by Webb is the ice giant's polar ice cap. Uranus is unique among planets because it rotates on its side with an axial tilt of 98 degrees. This extreme tilt causes Uranus's seasonal changes to be very peculiar, with its poles experiencing long periods of continuous sunlight followed by years of total darkness. Currently, it is late spring at Uranus's north pole, which is clearly visible in Webb's images. Compared to when Voyager 2 visited Uranus, summer in the planet's northern hemisphere will arrive in 2028. Uranus's south pole is currently in a long winter following summer and is now completely plunged into darkness, unobservable, facing only the vast cosmos. Webb's images also captured several of Uranus's 27 known moons, including some small moons near the rings. Notably, this detailed image of Uranus was taken with just a 12-minute exposure using only 2 filters. This suggests that this is just the tip of the iceberg of what Webb can reveal about this mysterious ice giant. This object is named ARP 142, also affectionately known as the Penguin and the Egg. In this amazing photo, we witness the cosmic dance of 2 interacting galaxies, NGC 2936 and NGC 2937. While the Milky Way and Andromeda are 2.5 million light-years apart, the Penguin Galaxy and the Egg Galaxy are only 100,000 light-years apart, a relatively close distance on an astronomical scale. The Penguin Galaxy was originally a spiral galaxy like the Milky Way, but due to gravitational interaction with the Egg Galaxy, it has undergone significant distortion over the next millions of years. Eventually, these galaxies will merge into a single entity, triggering a violent yet gradual cosmic event. This image vividly captures the intricate interaction between the 2 galaxies. The Penguin Galaxy's tail, filled with gas, dust, and newborn stars, has changed dramatically during this collision. It is surrounded by a bright blue mist, indicating star formation. The Penguin Galaxy's beak is rich in gas and dust and is the most active region for starbursts, where stars are forming. The penguin shape located near the center of the galaxy in the image reflects the galaxy's original spiral shape before interacting with the egg. In contrast, the egg is an elliptical galaxy where stars are aging. Due to its compact structure and low gas and dust content, its deformation is less than that of the penguin. A third galaxy, a spiral galaxy in the upper right corner, attempts to steal the show in this image. Although it appears prominent in the composite image, it is much closer to us and does not belong to ARP 142. These galaxies continue the evolutionary process of cosmic merger, which will create new stellar regions and planet-forming zones. This interacting galaxy pair was photographed to commemorate the 2nd anniversary of the launch of the James Webb Space Telescope in July 2024. Cosmology is facing a major crisis, and this image taken by the Webb telescope confirms it. The image shows the galaxy cluster PLCKG 165, 7 plus 67, 0G165, acting as a giant gravitational lens, bending and magnifying light from distant objects behind it. However, something surprising in the image caught astronomers' attention. 3 mysterious points of light, not visible in earlier images taken by Hubble in 2015, are now clearly visible in the Webb image. They have been identified as a Type Ia supernova located in a distant background galaxy named supernova H0PE. This exploding star was affected by the gravitational lensing of cluster G165. What we see are not 3 separate supernovae, but multiple images of the same supernova whose light traveled along 3 different paths and was bent by the mass of the G165 galaxy cluster located between us and the distant galaxy. This is a stunning example of gravitational lensing, where light from a background object is bent by the gravity of a massive foreground object, creating multiple magnified images of the same event. Supernova H0PE is significant because it is now the most distant Type Ia supernova observed to date. Type Ia supernovae are used as standard candles in cosmology. They are objects of known intrinsic brightness that allow astronomers to precisely measure distances in the universe. These measurements are crucial for determining the Hubble constant, the rate of cosmic expansion. However, there is a growing contradiction in the field of cosmology. Observations of supernovae have helped astronomers calculate the Hubble constant at 75.4 kilometers per second per megaparsec. This value, derived from the local universe, contradicts the Hubble constant measured from the early universe using cosmic microwave background radiation data, which gives a lower value. This discrepancy leads to the so-called Hubble tension, suggesting there may be some fundamental missing links in our understanding of cosmic expansion. Discovering more distant supernovae like H0PE is vital for refining existing measurements and potentially solving this puzzle in cosmology. One of the most breathtaking achievements of the James Webb Telescope is its discoveries at the edge of time. Within just a few weeks, this telescope observed massive galaxies at record-breaking distances from us. challenging our existing astrophysical models. This is JADE SGS-Z140, the most distant galaxy observed to date. This galaxy existed only 290 million years after the Big Bang, meaning its light has traveled about 13.5 billion years to reach us. This galaxy is not only distant, but also unusually bright and large, with a diameter exceeding 1,600 light-years. Such high brightness suggests that its luminosity comes mainly from young stars rather than a supermassive black hole quasar, which typically causes high luminosity. The presence of ionized gas, such as oxygen, indicates that before we observed this galaxy, many generations of massive stars had already formed and evolved into such a huge and bright galaxy. Appearing so quickly after the Big Bang suggests that galaxies form much faster than previously thought. This discovery challenges existing models, which predicted that galaxy formation during this period would be slower. These stunning images taken by the James Webb Space Telescope show us the beauty and mystery of the universe in an unprecedented way. Each image takes us deeper into space, revealing stars, galaxies, and amazing nebulae details, reminding us that we are just a small part of a larger story, a universe beyond our imagination. Gazing at these wonders, we can feel a connection to the cosmos, realizing that the forces shaping distant stars also shaped us. The universe is vast. These images allow us a glimpse into endless beauty and our place within it.